Okay, hi guys, once again, this is Teacher Nicoy, and today we'll be discussing the basic calculus, week 6, day 4. Okay, just adjusting my microphone. Okay, today we'll be able to solve the derivative of a composite function using chain rule. Okay, so this is just like here using chain rule, so it's just the same. It's just like more examples. All right. Okay, so we have here first example is y equals to 3x squared plus 4x minus 5. All right, so and we have to raise it to the power of 5. All right, so here we all know that it is with this u to the power of n. So if we derive it, it is equals to n u and then n minus 1 du. So if we have u is equals to 3x squared plus 4x minus 5, and our du is equals to 6x plus 4. Alright, how we get 6x? By deriving 3x squared plus 4x. Okay, the derivative of a constant is 0. Alright, so we just need to substitute the values here. So derivative is equals to 5. Our u is 3x squared plus 4x minus 5 to the power of 4. Then our du is 6x plus 4. Alright. Then we multiply it. We have here 30x plus 20 times 3x squared plus 4x minus 5 to the power of 4. Okay, so if we simplify this further, did he simplify it further or not? Let's check it out. No. Okay, so what he did was just here. Okay, just here is already good. This one is much better. Okay, so that's our first example, just a simple power or generalized power rule. So that's one. And we head to the next example. Over here we have I have already tackled this example in the last videos. Y equals to square root with square roots, 3x cubed plus 4x plus 1. Okay, so we will have what we call it a review. Okay, so we can change that into what? 3x cubed plus 4x plus 1 to the power of 1/2, and then we derive it. It will have before we derive it, let's put it as u is equals to 3x cubed plus 4x plus 1, and our du is equals to 9x squared plus 4. And then we take if we derive that, it will be, let's focus a little bit here. Okay, it will be nu to the power of n minus 1 du. Alright, so we have here, what is our n is 1/2, so derivative of y is 1/2 times our u. What is our u? 3x cubed plus 4x plus 1 to the power of 1/2 minus 1 is negative 1/2. And then our du is 9x squared plus 4. Alright, and then we have here, we transfer it down below and make it a what you call that, the root form. So no need to 1 it, so we copy this, 9x squared plus 4 over 2 times I know, not times, but square root. Okay, so we have to make it bigger to square root of 3x cubed plus 4x plus 1. Alright, so this is our final answer. Do we have the same answer with him? 2x cubed. Oh, look. Okay, so he has no plus sign, so that's an error to the, and it makes still our students confused to this kind of mod, especially this is modular. So we better have a correct answer in the modules. Okay, so this is the correct answer. You have plus sign over there. Okay, so let's tackle the next example, the okay, so y equals to sine 3x square. It is also equals to sine 3x, so it's still the same. Okay, so what we're gonna do is we have u is equals to sine 3x. Our du is equals to what we have here. Sine x is cosine x. Okay, so we have here sine 3x derivative of 3x, and then du is equals to sine 3x times 3x, I mean times 3, or we're having it in the 3 sine 3x. Okay, so what is where did I get this 3 from? Deriving 3x. Okay, so we have that one, so we take the form un is equals to nu n minus 1 du. Alright, so what will happen to this is, what is our n? It is 2. Our u is sine 3x, and then n to the power 2 minus 1 is 1, so then times, and we multiply 3 sine 3x. Alright, and then we can multiply this one as 6, and then this one will be sine 2 3x. Okay, so this would be my final answer. Wait. We have a mistake. We have mistaken this one. Sorry for that. So supposedly this is cosine. Okay, also this one is cosine. And also this one is, no, that's okay. Wait. Okay, that is wrong. Supposedly cosine. Okay, so always remember, don't be don't forget this functions or the shortcut over here, no? So if we derive the derivative of sine 2x, it will be cosine 2x times the derivative of 2x. Okay, and then cosine 2x is 2. Okay, so we have here sine 3x times cosine 3x. Okay, so we have now the same answer. Okay, so sorry for the mistake once again, but good thing we have recovered it. So it's okay to commit mistakes. Just remember to to correct your mistakes. Okay, all right, and then we have here this example. We have the y is equals to 3x squared minus 5 to the power of 3. So still the same. We're gonna use 3 3x squared minus 5. This is a lot faster version, but it depends upon the function. Okay, 3x squared minus 5 square. What is the derivative of this? 6x, and then okay, the 6x equals to 18x. 3x squared minus 5 square. So that's it. It depends upon the function of how you will try to solve that. Okay, and then okay, so we have here this number, a letter E, which is y equals to 3u squared plus 4u, where u is equals to x squared plus 5. Okay, so we need to get this derivative. So what will happen is, okay, so we will derive it based on the u first. So the u is 6u. Always put du over there, plus 4 du. Okay, and then we all know that this is x squared plus 5, and then we have this x squared plus 5 plus 4 times derivative of x squared plus 5. Okay, then x 6x squared plus 5. What is the derivative of this? It is 2x plus 4 times 2x equals to y. We have here 2x here. Okay, we can get the 2x. We can factor it out. Maybe we can have 4. Wait, okay, 4. I can have 4 there. 4x times 3x squared. Oh, no. 3x squared plus 5, and then plus 2 here. Okay, so this will be my final answer. How come he has this one? Okay, I get it now. He simplified it. So we have here, look at this one. We have the same situation here, over here, and then he simplified it. So let's simplify this too. So this is okay, so we have here 4x, 3x square plus 15, 15 plus 2, and then we will multiply it to 12x cube plus, what is 15 times 4? So 15 times 4 is equals to 60. 60x, and then plus 8x, because 4x times 2 is equals to 8x. So we have 12x cubed plus 68x. So that is our derivative. Okay, so we have the same answer. Okay, now we have this exercises. I will give example. How about this one? Okay, so if you have this one right here, you will just use y equals to 1 over u. So you will use is u to the negative 1, because what will happen is when you have here negative 1 u, this will become negative 2, right? This is the example I'm taking. Also this one still the same. Also this one, it's just simple. It's just simple power rule. Okay. How about we have an example which is much difficult right here. I think much difficult if we combine these two. How about I have this one and my u is this one. Okay. So 1 over y is equals to 1 over u plus 1, and then my u is equals to 1 over 2x plus 1. Alright, so let's zoom in a little bit there. Okay, so what will happen is y is equals to u plus 1 to the power of negative 1, and then I will derive it. So when I derive it, it will be negative 1 u plus 1, and then here we have negative 2 d u plus 1. Alright, and then here we have here negative 1 u plus 1 negative 2 du. Okay, and then here we have here negative 1 u plus 1 negative 2, and the derivative of 1 over 2x plus 1. Alright, okay, and then it's too long, right? What is the derivative of this? So you will have you will use it again. We will okay, just note it here that this is 2x plus 1 to the negative 1. So what will happen is we will multiply negative 1 and 2x plus 1 to the negative 2, and then derivative of 2x plus 1. Okay. Equals to we will simplify later. Okay, so our u is we have, okay, later u plus 1 negative 2, and then negative 1 times 2x plus 1 negative 2, and then what is the derivative of this is 2. Alright, so we can now simplify. Okay, we can multiply this 2, this 3, I mean, so negative 1 times negative 1 times 2, it is 2, with u plus 1 to the negative 2 times 2x plus 1 to the negative 2. Alright, and then what you're gonna do there is so we substitute this 2x plus 1 over 2x plus 1, so 2 1 over wait, I'm gonna have it below, down below, so 1 over 2x plus 1, 2x plus 1 square times 2x plus 1 square. Can we, okay, it can be 2x plus 1 square multiplied by 2x plus 1 square. So we can cancel it. So the remaining is 2. Yeah, is that correct? I'm guessing it's correct. I've seen no. Wait. Here we have a problem. That's not correct. Why? Because we forgot to put the plus 1 over there, right? So what happened is we made a shortcut. So we make the long cut. We have here 2x plus 1, 1 plus 2x plus 1 square, and then 2x plus 1 square. Still the same. We can still cancel that. But we have still remaining of this one. So 1 plus 1 plus, 2 plus 2x over, and then we square it. Then 2x plus 1 square times 2x plus 1 squared. Okay, so we can cancel that one and this one. So what will happen is we have 2 here, and then we factor 2, 1 plus x square. Wait. That's not supposed to happen because we have a square here. So if we remove 2, if you put 2 there, if you remove 2 with that 1 plus 2x, it still have this power here. So we can make it as, what will happen is it will become 4, 2 plus, not 2, but 1 plus x square. So our answer would be, where's the square? Our answer would be 1 over 2, 1 plus x square. Alright, so look at how long how long it was before you get the final answer. So that should be what that will be happening to you right here. So this is easy right here. I'll give you an example here. So sine square root of u. So what you're gonna do is you will derive that, right? Derive that. So this is just a fast example. So we have we will not use that let you. So we have cosine square root u times derivative of square root of u. Okay, and then what will happen is you have cosine square root of u times, what is the derivative here? So you have this one as u to the power of 1/2. So 1/2, and then square root of, no, not square root anymore, but u to the power of negative 1/2, and du is 1. So we have here 1/2 u cosine square root of u. So that's your answer right here. That's just almost the same as that. Okay, and then we have number 2 right here. Okay, so that is easy. So in here you need to make the u dv plus v du. Right here also the v du minus u dv over v square. Okay, so that's it. So how about do you need an example for here? Okay, just an easy example. We have y is equals to, let's not use 3x, but just almost the same, 5x minus 1, 3 times, but this one is x, just x square minus 3 power of 4. Okay, so that is our example. Let me just erase this for a minute. Okay, so what you're gonna do is you have u here and this is v. Alright, so we're gonna use the UDV plus VDU. So our U is equals to 5x minus 1 cube. Okay, and our DU right there is 3 times. So this is a long equation. 3 times 5. No, not 3 times 5x minus 1 square derivative of 5x minus 1, which is du is equals to 5, so 15, because the derivative here is 5, so 5 times 3, 15 times 5x minus 1 square. So that's your du, and your v will be v is equals to x squared minus 3 to the power 4, and then our dv is equals to 4 x squared minus 3 cube. Let's zoom in a little bit. Cube d derivative of x squared minus 3. So what we have here is this one is 2, so 2x, so 4x times x cubed minus 3 to the power of 3. So we have that one, and then what we're gonna do is we're gonna follow this u dv minus v du. Okay, so I mean plus udv plus vdu and u vdu minus. Okay, we're gonna have the u first, which is 5x minus 1 cube, and our dv is 4x times x squared minus 3 cube, and then we have our plus sign, which has our v is x squared minus 3 to the power 4, and our du is 15 times 5x minus 1 square. Alright, so it is very, very long. This is why, but for me, what we have here, we have we're gonna try to simplify it a little bit. 4x times x squared minus 3 plus 15 times 5x minus 1 square, and then x squared minus wait, we forgot the power of 3 right here. X squared cubed to the power of 4, and then we can get rid of that one, 5x minus, or just this one. This one is okay right here. This is an okay, because if we simplify it further, it will be useless, and for what? It will just take a lot of time. Okay, so we have that example already for the udv plus vdu for this one, and let's take an example for wait about this one. We delete this. Okay, we delete that one. Okay, so this is already recorded, so you can pause for the answer right there. Okay, so let's have an example for this, just like this one. y is equals to, how about 3x plus 2 over, wait, I want to try this one. 2x plus 3 and 5x minus 1. Okay, let's alternate that. Okay, so first we have here a very disturbing one. So first we will try to derive that one. So 2x plus 3 over 5x minus 1 square, and then the derivative of 2x plus 3 over 5x minus 1. Okay, so to derive that, you need to make this as u and this as v. So we can have the form, let's put the form here, v, then du minus u dv, and then over v square. Okay, so our u is 2x plus 3, and to have that du is equals to 2x. How about the v? V is 5x minus 1. Our dv is just, oh wait, what is just 5x, just 5. Okay, so we have now our du, v, and dv, so we can have this already, right? Okay, so we just copy this one. 2x plus 3, 5x minus 1 square. Then we multiply that with this one, v. Our v is 5x minus 1. Our du is 2. Minus our u is 2x plus 3. Our dv is 5 over v square, so 5x minus 1 square. Alright, and then we have here, just copy that, 2x plus 3 over 5x minus 1 square. Okay, so this will be 10x minus 2 minus 10x. Always remember this has a minus over here. Okay, so 2 times 2x times 5 is 10x. 3 times 5 times negative is negative 15 over 5x minus 1 square. Alright, and then we have here y, 2x plus 3 square. Why did I do that? Square over 5x minus 1 times 10x times 10x minus 10x is 0, negative 17 over 5x minus 1 square. So what we have here is we can multiply 3 times 17, so 3 times 17, negative 17 is negative 51. 2x, or we can have it, okay, wait, 2x plus 3 square over 5x minus 1 times 1 over 5x minus 1 square. Okay, so we can distribute the square, so it can be square here and square there. So it is possible. So we have here negative 51 times times 2x plus 51 times 2x plus 3 square over 5x minus 1 square times 5x minus 1 square. So we can have negative 51 times 2x plus 3 square over 5x minus 1 to the power of 4. Alright, so will be our final answer. Okay, so we have both examples of the two functions multiplied and two functions divided. Okay, so that's it for week 6. Week 6 is very tiring to explain. So many examples, and it's a lot challenging than ever. So hope you learned something today, and tune in for the next week. Thank you. God bless.